Here we're asked to solve a linear system that consists of 3 variables and 3 equations. Let's begin by labeling these equations 1, 2, and 3. We can eliminate z using equation 1 and 2. Now to do that, we can multiply both sides of the first equation here by -3. That'll give us an equivalent system, negative 6x plus 9y plus 3z equals negative 21. And at this point you can see the variable z is lined up to eliminate. So when we add these equations together, we're left with negative 3x plus 14y equals negative 23. Now let's eliminate z again, this time using equation 1 and equation 3. Using these equations, we can eliminate the variable z if we multiply both sides of the first equation by 2. That'll give us an equivalent system, 4x minus 6y minus 2z equals 14. And we can see the variable z is lined up to eliminate. So when I add these equations together, we're left with 8x minus 7y equals 31. Now we're left with 2 equations with 2 unknowns. Now we can solve the resulting linear system here by elimination. We can eliminate the variable y if we multiply both sides of the second equation here by 2. That'll leave us with an equivalent system here, where the second equation is 16x minus 14y equals 62. Now adding these 2 equations together, we can eliminate the variable y. That leaves us with 13x equals 39. And then dividing both sides by 13, we have x equals 3. Now at this point, we begin the process of back substitution. Here we'll substitute x into this first equation of this system here. Substituting x is equal to 3, we have negative 9 plus 14y equals negative 23. Adding 9 to both sides, we have 14y equals negative 14. And then dividing by 14, then equals negative 1. So we have x, now we have y. All that's left to do is back substitute into one of these original equations to find z. Let's use the first equation. Here we'll substitute 3 in for x and negative 1 in for y. And that'll leave us with 6 plus 3 minus z equals 7, or 9 minus z equals 7. Subtracting 9 on both sides, we're left with negative z equals negative 2, or z equals 2. And now all that's left to do is to present our solution as an ordered pair, or an ordered triple, that is. And so here the simultaneous solution is 3, negative 1, 2.